So in this video we are going to understand if they give you the characteristic equation from which we care whether we can identify the system is stable or not. Let us see. For that, two conditions should be satisfied. Okay, all the coefficients of characteristic equation should be real and of same sign, and no coefficient should be 0. Coefficient of s should not be 0. So let us try to understand. Now question arises whether we can say that the given characteristic equation with these two conditions, whether it is absolutely stable, whether it is confirmed that it is stable or not. No, it is not confirmed with these two statements, because the thing is, last part of the video you will be observing one polynomial. In that polynomial I will tell you if the condition, these two conditions are also satisfied, but still the system can be unstable also. But for now we'll just see that these two conditions, whether we can say the system is stable or not. We'll try to understand that. Now the given problem is, you can see over here, the first and the foremost thing you have to see the signs of the given equation. The system is stable only it is quite possible that an equation with all its coefficients non-zero of the same sign may not have all the roots in the left half of the S-plane. So it is necessary that if you draw the S-plane, left half of the S-plane, the roots should be there. The roots in the sense S value should be there, poles and zeros, right? So characteristic equation basically means the denominator, that means pole should be on the left half of the S-plane. That means this part, left side. Okay, so we'll try to understand, then only we can say the system is stable. For the system to be stable, the pole should be according to the characteristic equation, pole should be left half of the S-plane. Okay, so these two conditions we'll see. So given question we are having, first thing you have to see whether the coefficients of the all the coefficients of the characteristic equation having are real, and as well as whether they are having the same sign. Here you can observe positive, 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 all the terms having what? Positive sign. So therefore we can say that the system can be stable, but we have to satisfy the second condition also, which is nothing but the coefficient should not be 0. Coefficient in the sense there should not be any missing term. Missing term is because of what? See here, the first variable is s power 5. Rest variable should be what? In decreasing order. S power 4 should be there, s power 3 should be there, but s power 3 is not there. Directly s power 2 has come. Check whether s power 3 is there in this equation. No, s power 3 is not there. That means if s power 3 is not there, so we can just add one s power 3 by writing 0 s power 3. Yes, it is possible. But the thing is that 0 has come as the coefficient of s. What I said here, what it is mentioned here, coefficient should not be 0. But here it is given that here we have tried to bring that s cube, since that term was missing, by adding one coefficient. That coefficient is now 0. But it is not possible, because the system is stable only if the coefficient should not be 0. So but here the coefficient is 0. So we can say that this system is unstable because of this condition. Okay, so for stability we are going for Routh's criteria also, that we will be discussing in the further videos. But for now instance, we can say by these two conditions instability for sure, instability. But if the system comes as stable, we'll try to analyze that. Okay, so the system is unstable. Why it is unstable? Because the s power 3 term is missing. You can write it as missing, or you can write it as the second condition, that the coefficient of that is 0. Coefficient of s power 3 is 0. Okay, that thing you're getting. Let us see few more problems. The second question is here. Here you can observe positive sign, then negative has come, then positive, positive, positive. Now all the equations is all the terms is not having the same sign. What you are going to do? That the same sign is not there. So same sign is not there. Next, one more condition was there. We'll just check. Anyways, it is not satisfied because both the conditions should be satisfied for the stability, for the system to be stable. Okay. Now, s power 4 is there, 3 is there, right? 2 is there, 1 is there, you can write it as 1, then s power 0 is there, this you can write it as s power 0. Now the coefficients, if you observe, all the terms are there is no missing term, so we can surely say that second condition is satisfied, but first condition is not satisfied. That is nothing but same sign, the system is unstable. Both the conditions should be satisfied. The system is unstable because of what? Same sign is not there, the terms are having different sign. Okay, let us go for the third one. Here you can see it is starting from s power 3. In this equation s power 2 should be there, but where is s power 2? Not there. But we can add s power 2 by just writing 0 s power 2. Yes, s power 1 is there. S power 0 is there. Yes, s power 0 is there. Coefficient is 10. So one term is missing. The first condition, the second condition we have tried to analyze. So the term s power 2 is missing. Or you can write it as the coefficient of s power 2 is 0. Simple. For first condition, what was the first condition? Sign should be same, but here positive, negative has come, then positive. That means sign is also not same. When sign is not same, the first condition is only not satisfied, then we can directly say it is unstable. But still we are analyzing both the conditions. Okay, so here both the conditions are not satisfied because same sign is also not there. No same sign. Okay, no different sign. Let us go for one more problem. Now here you observe carefully. S power 4 is there, S power 3 is there, S power 2 is there, S power 1 is there. What is missing? Any term is missing or not? Yes, S power 0 is missing. Where is S power 0? There is no constant term, there is no S power 0 only. So first thing you can write it as S power 0 is missing. Missing in the sense we can indirectly say that the coefficient of S power 0 is 0. S power 0 coefficient is 0. So we can directly write S power 0 coefficient is 0. Okay. So what was the first condition? First condition we didn't see. That should be positive. All the signs should be same. So positive, positive, positive everywhere. So the first condition is satisfied. But the second condition is not satisfied. So the system is unstable. Okay, fine. So as I said before, I'll consider one more example that is very important, because in this example you will try to analyze, because all these examples, 4 examples I have taken, that 4 examples the system was unstable. Now for example, s power 3 is there, s power 2 is there, 2s plus 8 equal to 0. This is one characteristic equation. Now you will observe that two conditions should be satisfied. Positive, 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 all the signs are same signs. Then next thing is nothing but second condition we have to see, the coefficients should not be 0. That means there should not be any missing term. 3 is there, 2 is there, s power 1 is there, s power 0 is also there. That means all the coefficients having, there is no missing term. So all the coefficients, none of the coefficients is 0. So all the coefficients are there. So to both the conditions are satisfied, right? So both the conditions are satisfied. So what you can say from that both the conditions are satisfied, the system is stable. You cannot say this. That is where I am trying to tell you that for the stable systems, always remember, by this method, by these two conditions, we cannot confirm the stability of that system. But for unstable, we can say by saying that these two conditions or any one condition is not there, that's why it is unstable. For stability, we cannot say, because in this example, if you observe that when I solve this question, when I solve this equation, I will be arriving at the equation as factorized form as s plus 2 into s minus 1 by 2 plus j square root of 15 by 2. In the calculator you will be getting si. Okay, the same thing, s minus 1 by 2 minus j root 15 by 2. And now here you can see the 3 factors I have got, because it is s power 3, so 3 factors you will get, 3 s values you will get. Now when I write these s values, what you are trying to understand is, now if you observe, when I write s value is equal to minus 2, then s value is equal to plus 1 by 2 minus j 15 root 15 by 2, j or I you can write, okay. S is equal to plus 1 by 2 plus j root 15 by 2. Okay, just to take this one equate it to 0. So s plus 2 is equal to 0, that's why s is equal to minus 2. This also equal to 0 you put, equal to 0 you put, that side it will go, it will change the sign. Minus will become plus, plus will become minus, minus plus, minus plus. Okay, so here if I try to make this one, okay, j omega s is there, 0 is there, okay. So now minus 2 will be somewhere around here, s value, then plus 1 by 2, so I'll take this as half, and minus j somewhere here, minus j minus I root 15 by 2, okay, minus I root 15 by 2, complex number, so somewhere here root will be there, one more root somewhere over here, this is plus j root 15 by 2. So here you can observe that these two roots are on the right half of the s plane, right, it is on the right side, but this is on the left side. But right side it has come means we can say that it is unstable, but by our conditions both the conditions are satisfied, but still it is unstable, okay. So unstable, so whenever it is coming both the conditions are satisfied, we have to check with the Raoult's criteria that will be determining the absolute or necessary condition for the stability to be satisfied. Here both the conditions are satisfied because it is having same sign, right, plus 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 everywhere, and there is no coefficient with 0, coefficient as 0, right, s term is not having any 0 coefficient. If you observe, s power 3 is there, 2 is there, 1 is there, and s power 0 is also there, there is no missing term, so no missing term, or we can say that, or no missing term, or all the coefficients of s term is not equal to 0, so all the coefficient is non-zero, so all coefficients of s term is non-zero, it is not 0, okay. So both the conditions are satisfied, or you can say that there is no missing term, okay. So both the conditions satisfied, we can say that it is a stable system. But the problem comes here, we cannot directly say it is stable system, because when I try to take this, analyze this equation by taking the roots, that means by solving it in the calculator, you will be getting it as factor as s plus 3 into s minus 1 by j4 into j or I, okay, in the calculator you will be getting it as I, so s minus 1 minus j4, these two are repeated roots we are getting, okay. So anything is fine, we'll try to plot it, okay, s plane will try to plot it, j omega complex one. So s plus 3, that means s value is minus 3, because equal to 0 you will put s is equal to minus 3. So s is equal to minus 3, it is on the left half of the s plane, there is no problem in that. But when I see these two terms, there is a complex value, right. So complex value, if you say, s term will be equal to what, s is equal to plus 1 minus j4, and s is equal to, from this, plus 1 plus j4, just equate it to 0, I hope you understand. So this sign will change, that's it, okay, the signs will change, okay. So plus 1 means here, plus 1 is there, j4 means somewhere here, j4 will be there, positive j4, and negative j4 somewhere over here. So the point will be here and here, but this is on the right half of the s plane, the system is unstable, but these two conditions are satisfied. So that means these two conditions we can directly, by seeing the equation, we can say for unstable system. Stable, if it is coming, if that means at the conclusion of this video you have to understand that two condition, if it is getting satisfied, we have to go for other method for checking the stability. That means you can take the roots and check, or we can go for Raoult's criteria, which is on the further videos we'll be discussing. For instability, by just saying the equation instability. If any one condition is not getting satisfied, it is unstable. Both the condition are satisfied, it is stable, but further calculation must be done in order to confirm it is stable or not.